Hello and welcome to another video on differentiation rules. In this video, we are going to discuss about implicit differentiation. In past several videos, we discussed about different techniques of differentiation, and the function that we have considered so far are of the form y equals f of x, or y is expressed explicitly in terms of x. But when we are doing differentiation, we might come up with some relations like this one right here, where we cannot isolate y, or we cannot solve for y, and sometimes it might be challenging, sometimes it might be impossible to do that. So in such cases, we still want to find the derivative of y with respect to x. So in such cases, what we do is we use a special technique for differentiation, which is called implicit differentiation. And these type of relations are called the implicit relations, okay? So before I do that problem, one thing, so usually in this type of relations or in this type of equations, we'll see x and y, two different variables. So y is an unknown function here, okay? Y is a function of x, still y is a function of x, but it's unknown. What y is, we don't know. So when we are doing the derivative, when we are finding the derivative of y with respect to x, it's just like f prime, or it is dy over dx, that is differentiating y, the function y, with respect to x. Now, if we have y, it's just dy over dx, that's the derivative. But if we have something like y squared or y cubed, so in that case, we have to use the chain rule that we discussed in the previous video. So the derivative of, for example, if we are differentiating y squared with respect to x, then that derivative becomes, so we'll differentiate y squared, which is 2y, and then derivative of y is dy over dx. So it's nothing new here, okay? We are just using the chain rule. So the derivative of this function y squared is 2y, but we are differentiating with respect to x, so we have to find the derivative of y, which is dy over dx. So this is basically using the chain rule, so don't get confused with this, okay? So now here's the first example. So we want to find the derivative dy over dx for this given equation, okay? So now what we do is we'll take that equation first. So let's do A. So we'll take that equation, x squared plus y squared equals 10. And then we'll differentiate this, okay? So differentiate this with respect to x, because we are finding the derivative with respect to x, okay? So writing this with respect to x, I might use w dot r dot t, which means with respect to, okay, if I use that later in other examples. So differentiate with respect to x, so differentiate both sides of this equation with respect to x. If we do that, then derivative of x squared is 2x, okay? And the derivative of y squared is 2y. Then we are differentiating with respect to x, so this should be dy over dx equals derivative of 100 is 0. It's a constant. So now here let's solve for dy over dx. So once we do this one, that's the first step. Then after that, we'll just solve for dy over dx, because we are just trying to find dy over dx. Okay, so we'll subtract 2x on both sides. So if we do that, we get 2y dy over dx equals negative 2x when we subtract 2x from both sides, okay? And then divide by 2y. So we have 2y here. So if we divide by 2y, then we get dy over dx equals negative x over y. Okay, so that is the derivative for that equation. Now the second part of that question is find the equation of the tangent line to the circle. So this is the equation of a circle at point 8 comma 6. So we want to find the tangent line at that point. Now for that, what we need to do is we have to find the slope, because we got the derivative. I mean, we have the point, we got the derivative. Now we need to find the slope of tangent line at 8 comma 6 is given by this. So slope m equals dy over dx at 8 comma 6. So we have to evaluate the derivative at that point. So the derivative is negative x over y. So that is negative x means 8 over y means 6. And that is negative 4/3. So that is the slope of the tangent line at 8 comma 6. Now we have a point, we have a slope. And that means we can go ahead and find the equation of the tangent line. So the equation of the tangent line is, so equation of the tangent line at the given point, which is at 8 comma 6, is y minus y1, which is 6, equals m, which is negative 4/3, times x minus x1, which is 8. Now let's go ahead and simplify this. Y minus 6 equals negative 4/3 x plus 32 over 3. Okay, now if we add 6 on both sides, we get y equals negative 4/3 x plus, so when we add 6 on both sides, we get 50 over 3. And that is the equation of the tangent line to that circle at 8 comma 6. Okay. Now you can pause the video and try doing this problem, and then you can resume the video and check your work. So we are going to do it now. So again, differentiate on both sides with respect to x. Okay, so differentiate both sides with respect to x. So when we do that, so the function on the left is sine xy. So we have to use the chain rule here and then also the product rule. So a lot of things here. So, okay, so let me write it this way first. So d over dx of sine of xy equals d over dx of x squared plus y squared. Now, the derivative of sine x is cosine x, so it is cosine xy times, then we need to find the derivative of this inside function. So we are using the chain rule here, okay? So the derivative of inside function is a product x times y. So we have to do the product rule here. So derivative of the product x times y, so we use the first function derivative of second plus second function derivative of first. So we are going to use that product rule. So first function is x times derivative of second function is dy over dx, because derivative of y is dy over dx, plus second function is y times derivative of first function, which is x, so it is 1, equals, now derivative of x squared is 2x plus derivative of y squared is 2y times dy over dx. Okay, now let's we need to solve this equation. We have to solve for dy over dx. So let's distribute this one and see what we get. So we have cosine of xy times x times dy. So let's write that x here, then dy over dx plus y times cosine of xy equals 2x plus 2y dy over dx. Now remember, our goal is to solve for dy over dx. So we have dy over dx in this term right here, and then we have dy over dx right here. So in order to solve for dy over dx, or in order to isolate dy over dx, we need to put those two on one side and rest of the things on the other side. So what we'll do is we'll move this over here, and then we'll move this over here. Okay, so when we do that, this is what we are going to get. So we get x cosine of xy dy over dx. Now when we bring that over here, so it's minus 2y dy over dx equals, now we have 2x. Now when we take this term to the right, we get minus y cosine of xy. Now, in order to solve for dy over dx, we need to factor it out. So let's go ahead and factor out dy over dx. Then we get x cosine of xy minus 2y equals 2x minus y cosine of xy. Now the final step, we are going to divide by this one on both sides. Okay, so we will divide by this term on both sides. X cosine of xy minus 2y. So the final answer is dy over dx equals 2x minus y cosine of xy divided by x cosine of xy minus 2y. Okay, so this is x. So that is the final derivative for that given relation. Okay, dy over dx is that. Now, this one, find an equation of the tangent line to the given curve at 1, comma 1. So again, we know the point. This is the point where we are finding the tangent line. So what we need is we need this slope. So in order to find this slope, we have to find the derivative dy over dx. So let's go ahead and differentiate this equation. So go ahead and differentiate that, okay, with respect to x. So when we do that, what we get is, so this is our function right here. So I'm going to write the derivative. So the derivative of y to the fourth is 4y cubed dy, dy over dx, because we are differentiating with respect to x, plus derivative of xy, x times y, so we have to use the product rule. So the first function is x times derivative of second function is dy over dx, plus second function is y times derivative of first is just 1. Then equals, on the other side we have x cubed, so derivative of x cubed is 3x squared minus derivative of x is 1 plus derivative of 2 is 0, so we don't have to write it. So let's go ahead and simplify this. Actually, we need to solve for dy over dx. So what we do is we'll factor out dy over dx from this. So dy over dx. Now we have 4y cubed plus x, and then we have this plus y equals. So actually what we can do is we can move that y on the other side. Okay, so equals 3x squared minus 1 minus y. Okay, now let's go ahead and divide by this term. So 4y cubed plus x, 4y cubed plus x. So when we divide by that, we get dy over dx equals 3x squared minus 1 minus y over 4y cubed plus 1. So this is the derivative. Now what we need is we need the slope of the tangent line at 1, comma 1. So the slope of the tangent line m is given by dy over dx at 1, comma 1. So let's go ahead and plug it in here. So we have 3 times x squared means 1 squared minus 1 divided by 4 times 1 cubed plus 1. And that gives us, so 3 minus 2 is 1 in the numerator. And then we have 4 plus 1 is 5 in the denominator. So that is the slope. We have a point here. So now let's go ahead and find the equation of the tangent line, okay? So the equation of the tangent line is the equation of the tangent line is, so y minus y1 is 1 equals m is 1/5 times x minus x1 is 1. So now this gives us y minus 1 equals 1/5 x minus 1/5 when we distribute that. And then if we add 1 on both sides, so we get y equals 1/5 x plus 4/5. And that is the equation of the tangent line to that curve at 1, comma 1. Now here we are asked to find the second derivative of for that equation. So find d2y over dx2. So in order to find the second derivative, first we have to find the first derivative. So let's go ahead and differentiate. So differentiate with respect to x. So when we do that, so we get 2x plus 2y dy over dx equals 0. Now we need to solve for dy over dx, so we subtract 2x on both sides, and then we get dy over dx equals negative 2x, and if we divide, so let's write 2y here, and then divide by 2y, okay? And that gives us dy over dx equals, so 2 cancels out, so negative x over y. So that is the first derivative. Now we are asked to find the second derivative. So what we are going to do is we are going to differentiate this again. So the second derivative d2y over dx2 equals, so we have to differentiate this one. Now what we need to do is we have to use the quotient rule. So remember, the quotient rule is denominator times derivative of numerator minus numerator times derivative of denominator divided by denominator squared. So when we use that, so denominator is y, so y times derivative of numerator, so we have negative x in the numerator, so the derivative is negative 1, minus numerator is negative x times derivative of denominator is dy over dx. Then everything divided by y squared, or the denominator is squared. So now we get d2y over dx2 equals negative y plus x times. Now, instead of putting dy over dx, we are finding the second derivative, so we don't want that first derivative right here. What we can do is we have dy over dx equals negative x over y. So we'll make that substitution. Okay, so instead of writing dy over dx, we are going to write negative x over y. So negative x over y, everything divided by y squared. Now what we have is we have d2y over dx2 equals negative y minus x squared over y divided by y squared. Now we have this fraction in the numerator. Okay, so yeah, we have this fraction in the numerator. So what we need to do is we have to um, yeah, we have to multiply by something here. Okay, so we have to multiply by y here, and then here you need to get rid of that denominator. So this gives us d2y over dx2 equals, when you multiply by y, we get negative y squared minus x squared over y cubed. So what we can do here is we can factor out that negative, so that gives us x squared plus y squared over y cubed, and then x squared plus y squared is, that is 49, because x squared plus y squared is 49, so this is negative 49 divided by y cubed, and that is the second derivative. Now let's look at one more question here. Okay, so the next question that we have here is find the equation of the tangent line and the normal line. So normal line means it is a line which is perpendicular to the tangent at the point of contact. Okay, so that's what normal line means. So we are going to find the equation of the tangent line and the equation of the normal line. Okay, so the first thing, we need to get the slope. We have the point. This is where we are finding those line, tangent line and the normal line. So first we need to find the derivative in order to find the slope. So let's go ahead and differentiate this equation on both sides with respect to x. So differentiate. So let's go ahead and do that. Differentiate with respect to x. Okay. So when we do that, we get 2x plus. So again, we have to use the product rule here. So first function derivative of second. Okay. Plus second function derivative of first, so that's just the derivative of x times y. Now minus 2y dy over dx is the derivative of y squared equals 0. Now what we need to do is we need to solve for dy over dx. Okay, so we have dy over dx here and here, so we'll put them together. So we'll factor out dy over dx, and then we have x minus 2y. And what we do is we'll take this 2x and y on the other side, which gives us negative 2x minus y, okay? And then if we divide by x minus 2y on both sides, what we get is we get dy over dx equals negative 2x minus y over x minus 2y. So this is the derivative. So we'll use this derivative to find the slope of the tangent line. So slope of the tangent line at 2 comma 3 is given by m equals, so we'll substitute x and y here in the derivative. So negative 2 times 2 minus 3 over 2 minus 2 times 3. Okay, so this is negative 4 minus 3, which is negative 7 over the denominator is negative 4. That means the slope of the tangent line is 7/4. Now the equation of the tangent line, equation of the tangent line is y minus y1 is 3 equals m, which is 7/4 times x minus x1 is 2. Okay, now let's go ahead and simplify this. So we get y minus 3 equals 7/4 x minus 7/2 when you distribute here. And then we get, when you add 3 on both sides, so we get y equals 7/4 x. Then when we add 3 on both sides, we get negative 1/2. So this is the equation of the tangent line. Now the next question is, we are asked to find the equation of the normal line. So for example, if this is the curve, okay, then the tangent line, so for example at this point, the tangent line looks like this. And the normal line is a line that is perpendicular to the tangent line at this point. So now normal line means this green line. That's the line that we are finding the equation of, okay? So one thing that you learn in college algebra is the slope of the perpendicular lines are the negative reciprocal of each other. In other words, if the slope of the tangent line is 7/4, then the normal line is perpendicular to the tangent line. That means the slope of the normal line. So slope of the normal line, let's say m, equals negative reciprocal of the slope of the tangent line, which is negative 4/7. Now the point of contact is same, which is 2 comma 3. So we can find the equation of the normal line. So equation of the normal line is y minus y1 equals, now the slope is negative 4/7 x minus x1, which is 2. Now let's go ahead and simplify this. So y minus 3 equals negative 4/7 x plus 8/7. And then when we add 3 on both sides, so we get y equals negative 4/7 x plus 29 over 7. And this is the equation of the normal line. We'll just do this much for this video. I'll see you again in the next video.